Last year, organizations globally lost an unprecedented $21 billion to cybercrime. At the same time, credential targeting is spiking. Attackers are aggressively hunting access tokens, driving a 37-fold increase in device code phishing attacks alone. And the primary target for this extraction isn't the enterprise monolith. Over 76% of the victims bearing these losses are small businesses. The traditional model of network intrusion, slow, deliberate lateral movement and noisy internal scanning, is obsolete. Adversary groups like APT41 and Storm 1175 are executing a new playbook defined by extreme speed. They rely on rapid edge exploitation to compress the time between their initial access and the final impact. The Byer Nichols threat brief for the first half of April 2026 provides a detailed roadmap for deconstructing this modern attack lifecycle. To counteract this environment, defenders must understand exactly how attackers are sequentially linking internet-facing vulnerabilities with advanced evasion and identity theft to execute double extortion campaigns. Modern breaches frequently bypass standard email phishing campaigns in favor of targeting the enterprise perimeter directly. This schematic illustrates the current trend in external exploitation. Adversaries are aggressively targeting exposed management servers residing in the DMZ, bypassing the firewall entirely. A prime example is exploiting Ivanti Endpoint Manager using CVE 2026-1340 for immediate administrative access. Simultaneously, tandem exploitation targets Fortinet 40 client EMS servers using recent vulnerabilities to compromise external-facing assets. It is not only financially motivated criminals deploying these fresh endays. Sophisticated nation-state clusters like UAT 10362 and UAT 10608 are utilizing the exact same methods. Their strategic goal is clear. They want a quick, reliable foothold on the edge of the network, rather than attempting immediate, noisy lateral movement into deeper, segmented systems. Even established flaws in ubiquitous tools like Adobe Acrobat and Microsoft Exchange remain heavily utilized as secondary access vectors. The timeline from a vulnerability's public disclosure to active automated scanning by threat groups is rapidly shrinking to mere hours. A single unpatched external service completely negates internal network segmentation. It grants the attacker the necessary leverage to begin credential harvesting from the outside in. Once the perimeter is breached, the attacker moves to the execution phase. Their immediate priority is evading local telemetry to establish hidden control over the asset. This architectural diagram compares execution environments to explain the mechanics of modern post-compromise malware like STX-RAT, which spreads via Trojanized installers for tools like FileZilla. STX-RAT bypasses traditional antivirus software by unpacking its payload entirely in memory, leaving no disk artifacts. The payload is further obscured by advanced cryptography like X25519 and ChaCha20 Poly 1305 to hide from memory analysis. The operational result is that the attacker achieves full interactive VNC-style remote control of the machine without triggering any visible indicators of compromise. Alternatively, some operators prioritize extreme persistence over in-memory stealth. The no-voice Android rootkit, for example, uses steganography and 22 distinct exploits to achieve deep root persistence that survives even a complete factory reset. Whether they use volatile in-memory stealth or deep rootkit persistence, modern threat actors are rendering traditional local endpoint protections ineffective. With hidden control established, the next step in the kill chain is harvesting credentials. This allows the attacker to pivot from the compromised endpoint directly into the organization's cloud infrastructure. This flowchart shows a traditional defense mechanism, browsers implementing application-bound encryption to block local malware. However, next-generation tools like Storm Infostealer utilize a different operational approach to defeat this defense. Rather than fighting the browser's protections, Storm avoids the local decryption process altogether, sidestepping endpoint telemetry. Its mechanism involves shipping the fully encrypted browser credential store directly to an external, attacker-controlled server. The decryption happens safely on the attacker's own server. This results in the successful, unmonitored theft of session cookies and authentication tokens. Attackers then use these stolen tokens to execute seamless session hijacking across the organization's various SaaS platforms. Identity theft has been effectively decoupled from the endpoint. If attackers can exfiltrate the encrypted package, local security tools simply cannot protect those cloud identities. With domain and cloud access secured, the intrusion reaches its final phase, the rapid deployment of fast-moving double extortion ransomware. Data from early April reveals a sudden reshuffling of major players within the ransomware ecosystem. This chart of top ransomware actors shows DragonForce surging to the lead, capturing 12.18% of the market share. Akira maintains a steady 9.92% share, relying on VPN-based intrusions and quick-turn encryption. The most notable shift is the dramatic resurgence of LockBit, leaping from rank 11 up to rank 2 in total volume. LockBit's rebound occurred despite heavy, coordinated global law enforcement intervention. The group's affiliates responded by rapidly retooling their infrastructure and resuming fresh leak site activity. Analyzing victim demographics reveals over 76% of all targets are small businesses, with the damage heavily concentrated in the manufacturing and technology sectors. The ransomware economy remains highly resilient and agile. These groups are efficiently monetizing automated, high-speed attacks against less defended mid-market organizations. Looking at the fully assembled kill chain pipeline, we see how these stages connect. Internal network scanning and physical lateral movement are no longer the most dangerous phases. The new critical pivot point is the extraction of identity materials, specifically session cookies and cloud authentication tokens. Because intermediate steps like STX RATs evasion and Storm server-side decryption are highly automated, the attacker's actual workflow requires very little manual effort. This automation allows adversaries to translate a single exposed edge vulnerability into full cloud and domain compromise in a matter of hours, rather than weeks. To disrupt this process, organizations need specific defensive circuit breakers. The first is drastically compressing patch cycles for all external-facing management services and VPN gateways. The second is aggressive identity hardening. Security architectures must assume that local endpoints will be bypassed and tokens will be stolen. The third circuit breaker is implementing continuous post-compromise threat hunting that focuses on in-memory anomalies rather than relying on traditional disk-based artifacts. Ultimately, the primary adversary advantage right now is raw speed. To survive the threat landscape detailed in this report, security teams must operationalize this intelligence. They have to secure the edge and lock down the cloud identity layer before the attackers can automate their path to extortion.